Hello, students. We're talking about coordinate geometry. So shapes on the coordinate plane, okay? Where geometry and algebra go dancing. And today we're going to talk about a new shape. We're going to talk about circles. Circles in the coordinate plane. So we have our new shape. It is a circle. What is a circle? How do you define it? How do you name it? How do we write about it? What can we do with it? How did people in ancient times draw circles? What tool do we use? Well, there's one right here that I found a photo of. You guys know what that's called? It's called a compass. How do you think they drew circles before they had metal? Interesting thought. So what's this measurement right here? And how does this tool draw a circle? Anyone remember what this distance right here is called? This is a really important measurement. Okay, and how do we use this tool to draw a circle? Well, it starts with where you stab your paper with that sharp point. And then let's say this was 3. If I was going to draw a circle, I would go out 3 and I would have a point right there. I would also go out 3 here and I would keep going. I would keep finding points that were 3 away from this center point. And I don't know if I'm going to do a good job here. Oh, not too bad. Okay, if I keep drawing points that are exactly 3 away from a center point, I'm going to create what shape? A circle. So a circle is what? A circle is, it's a shape. What's it made up of? It's made up of points. So a circle is a set of points that are equidistant. That's the fancy way to say the same distance away from a center point. So the most important point on the circle is actually not on the circle or in the circle. It's here. Is this in the circle? I guess this is in the circle. Okay, but this point right here where we stab the paper, that is the most important point of the circle because that defines where the rest of this points are around. And I should actually say in a plane. If you did this 3-dimensionally, if you had a point and you had all the points around it, what shape is that? A sphere. All right, so a circle is a set of points equidistant from a center point on a flat surface, on a plane. Okay. So this point is the most important. How do we name a circle? How do we name circles? Okay, what that means is in geometry, if you're gonna write about circles in a textbook, how do you know I'm talking about this circle and not this circle? Ooh, green. Or this circle. How do you know I'm talking about this one and not this one and not this one? How can I say, hey, look at the circle? And then you say, I don't know which one you're talking about, Miss Bliss. The way we name them is we name them by their center point because that's the most, important point on there. So if I say, hey, class, look at circle A, all your eyes would go here. So we can name circles by their center points. And maybe I'll name this one Q. Here's circle Q. Here's circle R. Here's circle D. Okay. So if I was going to write it, I would write in my paper, on my paper, I would write circle Q. This is the symbol for circle. It's just you hand draw a little circle. Some books put a dot in the middle, some books don't. The name of the circle is the center point. All right, what else do we know about circles? What can we measure in a circle? What do you think the most important measurement is? Okay, one thing we can measure in a circle is someone said in class, someone said pi. Pi is definitely an important number when we talk about circles. Does anyone know the definition of pi? It's not 3.14. That's not what pi is defined as. That's an approximation for pi, but it's not what pi is. Okay, well, let's talk about this. What's this kind of line called where it goes through the center? You guys remember that one? That is called a diameter. Use my pen. Diameter. Okay, that is usually abbreviated with a lowercase d. That's called the diameter. And that is an interesting measurement. What else can we measure? Oh, what's this one? What's this distance here? What's this distance here? I'm going to use a different color. What's this from there to there called? It's called the radius. Wow, that's bad. Radius. I think the radius is the most interesting measurement on the triangle. What else can we measure? On the triangle, I just said triangle, that's weird. On the circle, I think the radius is the most interesting measure on the circle. Actually, circles and triangles are related. They're actually very closely related. Let's think about that some more. Okay, what's this called if you measure all the way around? If you cut this length, like if this was a string and you stretch it out, what is that distance called? All the way around the circle. Or yeah, that's the circumference. Circumference. Like circus. Circumference. Okay, for that we use a capital letter C. What's this? That's the distance. It's like the perimeter of a circle. We don't talk about the circle's perimeter. We talk about its circumference. Okay, so pi is actually, is it easier to measure around the circle or through the center of the circle? Is it easier to measure the chord of longest length or the distance around it? The diameter or the circumference? It's way easier to measure a diameter because it's just straight, it's just flat. It's hard to measure this unless it's a string and you can stretch it out and put a ruler next to it. So a lot of people studied this and they found that the circumference would go across the diameter about 3 times in a little bit. Okay, so pi, this Greek letter of the alphabet, is used to represent any circle's circumference divided by its diameter. Circumference divided by diameter. Another way to say that is if I take this diameter, it would fit 1, 2, 3, and then we would need a little bit more to finish the circumference. The diameter would go around the circle exactly 3 and a little bit exactly. Okay. Oh, there's another formula. So we can measure its circumference, we can measure its diameter, we can measure its radius. We have an easy way to find the circumference, which is to measure the diameter and then multiply it by this cool irrational number pi. What else can we measure? We can find a circle's area. So if I want to talk about the area of a circle, there's a formula for that. I can show you where it came from. There's actually a really cool video, but maybe we'll do that later. So this is pi r squared. So if you know the radius, you can find the area of a circle. That's the only measurement you need, really. If you have the radius, you can double it for the diameter, and then you can find the circumference. So the radius is really the coolest measurement on the circle. All right, now the cool part is we can actually write the equation of a circle. So I can type a formula into Desmos, and then it will give me the equation of the circle. This circle, do we know it's well, what's the most important point? The center, right? What are the coordinates, since this is coordinate geometry? What are the coordinates of the center? Well, this is the origin, so the coordinates of the center are 0, 0. That's the center. Okay, and how can I find the radius? Well, this one's set up really nicely. From here to here is the radius. And in this problem, how long? From 0 to 2 is 2. So this circle has a center at 0, 0, and it has a radius of 2. And this is the formula. X squared plus y squared equals 4. If I type that into Desmos, I'm going to get this beautiful purple circle. Does that look like anything? Does that look familiar to you? Okay, remember I was just saying the circles are related to what? Triangles. Oops, I want this one. Hey, that looks like what? Oops. Doesn't that look like a formula we've been playing with? That looks like the right triangle theorem. I could make it even look more like that if I change the 4 into what? I could change it into 2 squared. 2 squared is 4, right? And this has a 2 right here. What's the right triangle theorem? A squared plus b squared equals c squared. So a circle is actually related to a right triangle. Isn't that cool? All right, check this out, you guys. So why? Maybe I'll do that. No, I did it here. Okay, so if I choose any point on the circle, I'm going to choose this point right here. And I think I'm going to grab a different color. I'm going to get rid of this. I'm going to get rid of this. Okay, so I'm going to choose this point right here. What's the name of this point? What's the name of this point? I'm going to call it XY. We're talking coordinate geometry. So I'm going to label this point as XY. So how far is this? If this coordinate is X, okay, this is the X-axis, right? So I need to go this far. And then what's this coordinate up here? This is Y, right? So how long is it from here to here? It's actually X units. Maybe I'll call this X1, Y1. Maybe that's a little clearer. Okay. Hey, look at this shape. Do you see it? What shape is that? That's a right triangle. Okay. And what do we know about the radius? We know the radius is 2. Because the radius everywhere on this circle is 2. How long, if this is X, how long is this? Y. All right, do you see it? X squared plus Y squared equals 2 squared. It's the right. And if you move these points, it doesn't matter. You're still gonna, everywhere in the circle, you're gonna be creating right triangles. Okay, and always these two values, no matter how they change, have to have a sum of 4. Kind of cool. All right, let's look at some more. So I'm gonna open up this. I just told you, so here I have X squared plus Y squared is R squared. And I'm just gonna show you if R, this is called a slider. If R becomes a bigger number, we just had 2, right? This is the one we just had. The R was 2. If R gets bigger, what happens to the circle? It gets bigger. Okay, so if you change the radius, it's going to change, or if you change this R value in this formula, it's going to change how big the circle is. Woo. And all circles are similar, by the way. Okay, that's kind of cool. All right, here is the equation of a circle. So the important information is the center, which we call HK. So it has a X coordinate and a Y coordinate. And then the radius we've already looked at a little bit. This is important. This is the formula. This is, I want you to write, anytime you work with a circle, with the equation, I want you to write this every single freaking time. Okay, write it over and over and over again. It's a really good way to memorize. So every practice problem you do, every test problem you do, I want to see this formula written down. That's too much. Come on, you can do it. Okay, just take time, memorize it, get used to it. Okay, let's play with changing the H. Let's see what that does to this. Okay, so you can see it set up right here. I have X minus H squared plus Y squared equals 9. What's the radius of this circle? I'm going to move this to 0. Okay, notice the circle, it has a center at 0, 0. What's the radius of this circle? 1, 2, 3. Okay, because 3 squared is 9. All right, now I'm going to drag this around. So I'm going to make H equal 5. Which way did it go? It slid over. This is a horizontal change. That's one reason why they chose H. Okay, and I can also move it, slide it around. Woo! Okay, so I can slide it back and forth. If I change this number, the number right here, that's what this is saying, it's going to move the center of the circle horizontally. All right, what if I change the K, the one inside with the Y? What do you predict that's going to do? If I make K go up, the circle goes up. So if K is 4, the center of the circle is at 4. And if K is at -3, the center of the circle is now at -3. Kind of cool. All right. So what's the center and the radius of a circle with this equation? What did I just say? I said every problem, I want you to write the formula. So for this one, I'm going to write it right below it. X minus H squared plus Y minus K squared equals R squared. That's the formula. Write it every freaking time. Okay, now we need to identify the center and we need to identify the radius. You guys know either of those? Well, I know that the radius squared is equal to 1. These are equal. So if I square root both sides, then the radius, square root of 1, what times itself is 1, is 1. Okay, I found the radius. I still need to find the center. The center is defined as H comma K. Okay, so I can just look. What's the H number? H is 4. And what's the K number? K is 9. Done. Okay, I could check myself and I could see what this looks like. So I can move the H to -4 and the K to the H to 4 and the K to 9 and the R to 1. So I can move the R to 1, get a unit circle, and 1 unit for the radius. And then the H was 4 and the K was 9. Whoa, I lost it. Okay, that's what this looks like. Okay, it has a point. You can see the point right here. I can label it 4, 9. And the radius is, I could probably label the radius somehow, but I didn't program that this time. Okay, so the h is 4, the k is 9. We have 4, 9 for the center, and the radius is 1. Cool. All right, let's try again. This time I'll write the formula on the top since I had a little room. X minus h squared plus y minus k squared equals r squared. You know the radius? What number times itself is 64? R squared is 64, so r is 8. And r is 8. I'm not going to show work for that one. What is h in k this time? H comma k. H is 4 again. Uh-oh, watch out. What's k? You see the difference here? See this minus and this plus? That means k is -3. But it says +3. Yeah, but look right here. Okay. We didn't write -4 right here, did we? Okay, so the center is 4, -3, and the radius is 8. How about this one? Okay, I'm going to write the formula. X minus h squared plus y minus k squared equals r squared. Okay, so for this one, we know that r squared equals 13. So I'm going to square root both sides. The square root of r squared is r, if we're taking the principal square root. So the radius is the square root of 13. That's interesting. How about the center? What's h and what's k? What's h and what's k? H is -2 and k isn't there. It's 0. So there's the center and there's the radius. This is the center. All right, so what do we have to be careful of when we use this formula? The main thing to remember, just remember, what do we have to remember? The minus, this minus sign minus h, is already in the formula for the center. So when you're looking at this -4, you actually need the opposite. This is the only place where students get confused, right? So make sure that you understand that when you are, trying to find the center, the minus sign's already in the formula. So it's just like this +3 has to become -3. And this +2 has to become -2 for if you're locating the center. Now, I'm going to skip that one. Write the equation of a circle with center 6, 2 and radius h. Okay, that's not bad. We know this is, we know this is h comma k. And we know this is r. So the radius is 8. And we know that h is equal to 6 and k is equal to 2. That's all the information I need. So I'm going to write my formula. X minus h squared plus y minus k squared equals r squared. And then I have the x and the y in the parentheses, and the squareds are going to stay here and here. And then I'm just going to change out these values. So this is going to become x minus what? X minus 6. And this is going to become y minus 2. And this is going to become 8. You could leave it like that, but this we usually evaluate because I know what 8 squared is. So I'm going to just do one more step here. The best equation for this circle with a center at 6, 2 and a radius of 8 looks like this. This is your best answer. You just wrote the equation of a circle. How cool is that? All right, how about this one? This one we have to work a little bit harder for. So what information are we trying to get off this picture? We're trying to get the center. If I know the center and I know the radius, then I can write the equation of the circle. So where is the center of this circle? It's nice, it's at the origin. Okay, so h is 0 and k is 0. And then remember, this is h comma k. The radius we use an r for. How? 2 point something? It's not 2 and it's not 3. It's going through right here. I don't know what that is. How we need a different way to find the radius for this problem. So what you have to do is you got to work for it. So circles are related to right triangles. Here's a beautiful little right triangle. And if I can figure out this, then I know my radius. Okay, so how long is this? 1. How long is this? 2. Okay, and I'm going to do right triangle theorem. Okay, so I have 1 squared plus 2 squared, and that's going to be my radius squared. Maybe I'll just do it over here. I got a teeny tiny right triangle. I'm going to use my right triangle theorem. I have a 1 squared, I have a 2 squared, and that's going to equal my radius squared. So 1 plus 4 is 5. Radius squared is 5. And if I want the actual radius, it's the square root of 5. So this is the square root of 5. Which means this is also the square root, and this is also the square root of 5, and this is also the square root of 5. Okay, let's write our formula. More times you write it, the better you're going to have it memorized. Okay, it is all over the SAT, by the way. All right, we got x minus 0 squared, and y minus 0 squared. And square root of 5 squared. What's the square root of 5 squared? 5. It's like the square root of 25, which is 5. Right, and then x minus 0 is just x, so y minus 0 is just y. This is a really good answer for this problem. And I could type this into Desmos and see if it looks like that. And it will. All right, how about this one? Ooh, this one has a center somewhere else. What is the center of this circle? The center of this circle is -1, 2. Okay, so the first thing we have to do is find the center. The other thing we have to do is find the radius. Okay, the center of this circle is h, k, and in this problem it is -1, 2. And the radius, I don't know the radius. Oh, look, that's nice. This is 1, and this is 2. And we just did the problem. Oh, I almost made a mistake. Okay, we got to get out to the, oh, we have to choose. This is interesting. Okay, I almost went to the origin, and that would have been wrong. So I need to choose a point on this circle that's exactly where things are crossing. So this point is not on the circle, so I can't use that triangle. That would be not right. I could go out to here, but I don't know the coordinates of this point, so that's actually not a good choice. What I need to do is I need to find a point on the circle. Like this is a pretty good choice. This one's a pretty good choice. This one's pretty good choice. How am I choosing? I'm not choosing this one, not choosing. I'm going to choose this one. That's a pretty good choice. Okay, now why? Because it's right where these lines are crossing. So I can count really perfectly to there. So I'm going to draw my right triangle right in here. Okay, and I need this. I need this radius right here. I need this beautiful radius from the center to this perfect point on the circle. So I'm going to count that. That's 2, and that's 2. Hey, you guys, what kind of triangle is that? It's a right triangle. It's isosceles. It has two sides the same. Does anyone know what this is? It's kind of, this is in my way. It's a 45, 45, 90 triangle. So if these are both 2, this is 2 times the square root of 2. I love special right triangles. They're everywhere. So the radius in this problem is 2 times the square root of 2. All right, I have my information. I'm going to carefully shove it in. So we got x minus h quantity squared, and we have y minus k, that quantity squared, and that's going to equal r squared. Okay, I'm going to do my minus -1 squared, and y minus 2 squared, and 2 square roots of 2 squared. That's a lot of 2's. That's okay. All right, so do you see here that there was a -1? The center of the circle was moved off the origin. It was translated 1 to the left, okay? Which means that in the formula, it's going to be a +1. And then here we have quantity y minus 2 squared. 2 times the square root of 2 squared. I'm going to do that off to the side. 2 times the square root of 2 squared. That's 2 times the square root of 2 times 2 times the square root of 2. Now I'm going to rearrange my terms. I'm going to put 2 times 2 next to each other, and square root of 2 and square root of 2 next to each other. And that's 2 times, I'm going to make that a 4. What's the square root of 2 times the square root of 2? 2. Or you could say that's the square root of 4. And what's the square root of 4? 2. So all of that equals 8. That was a lot of work to show. 2 times 2 is 4. And the square root of 2 times the square root of 2 is 2. And 4 times 2 is 8. This is the answer to this problem. Yay! Ooh, I like this one. This one I put on the quiz, and I didn't teach it in class. So hopefully you're watching this video right now. Determine whether the given point lies on the circle. All right, here's how you do this. First, we write the equation of the circle. So I'm going to use this is h and k, and this is r. Okay, and I'm going to write the equation of the circle. Okay, and I'm going to do minus -1, and I'm going to do -1, and I'm going to do 4 squared. All right, I got my equation of my circle. Now I'm going to see, I'm going to put in to this equation, this is the equation of the circle. Okay, I'm going to test. I'm going to test and see if the point 2, 4 works. I'm going to see if 2 for x and 4 for y is going to make this equation true. So that's my answer. That's my equation. And now I'm going to do my test. I'm going to substitute x for 2. And what am I going to change the y into? I'm going to change the y into a 4. And I'm going to see, is that going to equal 16? If it does, that point's on the circle. If it doesn't, that point is not on the circle. So 2 plus 1 is 3. 3 squared is 9. 4 minus 1 is also 3. 3 squared is 9. And does 9 plus 9 equal 16? 18 is not 16. So guess what? 2, 4 is not on the circle. I'm going to go to Desmos and I'm going to plug in this information. So I'm going to make h -1 and k1 and the radius 4. I'm going to make h -1 and I'm going to make k1 and I'm going to make the radius 4. Okay, that is what this circle looks like. Okay. And the point I was wondering about was this point 2, 4. Okay, this point 2, 4. I was wondering if that was on the circle or not. And if you drew it bad, you might not be sure because those are pretty darn close together. Okay. But if you look on Desmos, is this point on a part of the circle? No. Where is it? If it's not on the circle, it has two possible places. It can either be outside the circle or inside the circle. And this one is outside the circle. So if you use these numbers, 18 and 16, how would you know if it's outside or inside? Well, 18 is greater than 16. If it was exactly 16, it would be exactly on the circle, but it's further from the center. So therefore, this is how you say therefore in a math class. Therefore, 2, 4 is not on the circle. It is outside the circle. This is a really good answer. I think I put one of those on the quiz. Okay. This is a challenge and this is cool and fun. So if you're not up for a challenge, goodbye. If you are, hang out because this is awesome. Really good for Algebra 2 stuff. So right now, this equation doesn't have any parentheses in it, and it would make no sense for the radius to be a negative number. So there's some really cool math that we do for this. I need to change these into things with parentheses. And if you remember your factoring and you remember completing the square, there's some cool math that you can do for this. So I want to turn this into something that looks like this. I don't know. Your Algebra 2 teacher might need to teach this again. Okay, I'm going to randomly add 25 right in this middle of this problem. I'm going to do it on both sides. Okay. Why would I randomly add a 25 in here? Okay, because I have an x squared and I have a negative 10x, which I want to split evenly between these two boxes. And I want to know what number completes this beautiful perfect square. I need x something and x something. I need, if this is a square, these two sides are going to match. I knew that if I put a 25 right there in the corner, that I would get x minus 5 squared, which is really smart. If I randomly put a 25 right in here into this equation, I would get a beautiful, this is what I'm looking for, right? I'm trying to find the center and the radius. So I need to know, I need it to look like this because I need it to look like I'm trying to get to x minus h squared, right? And the way I had it didn't look like that. All right, I'm gonna do the next thing here. Oh, that's nice, it's positive now. Okay, so I got the first part right. I'm gonna do the same strategy so that I can complete the square for the y, the k value. Okay. This is where I'm trying to get to, right? So this part's good. I already know the h is 5. I'm gonna leave that alone. The nice thing about equations is you can take control of them. Wow, glitching. Let's try that again. Okay, this I'm gonna leave alone. And now I'm gonna try to complete a different square. And the square I'm trying to complete now has a y squared in the corner and it has 2y. If this is a square, I'm gonna put 1y in each square. I'm gonna put 1y there and 1y there. And the question is, what do I have to add to complete this square? Remember, I want y times y. And this is all positive, so I'm going to put a +1 here and a +1 here. And what goes in this box if I'm going to complete the square? Well, I need to add a +1. So I'm going to do y squared plus 2y plus 1 equals 3 plus 1. Same thing on both sides. Keep it balanced. It's algebra. Okay, now why is that super smart? Because now I can see if I have a 1 in here, if I have a 1 right here, which I randomly added into my problem because I'm cool like that. Okay. Now I know that this is the same thing as the quantity y plus 1 squared. Those match, those are the sides of the square. They are both the same, so I can write it as a perfect square. And that equals 4. Hey, do you know the center and the radius? I do. Okay, what's the center? So the center is h comma k. Center. In this problem, it is 5 comma -1. And what's the radius? The radius is 4. 4 is what number squared? That's 2. Okay, did I find the center and the radius? Yes, I did. Graph the circle. Okay, I'm gonna graph it. 1, 2, 3, 4, 5, -1. There's the center. X, this is Y. And then I'm going to go out 2 from here. So I'm going to go, this is -1. This is -2. I'm going to go out 2 this way. I'm going to go out 2 this way. And I'm going to go down 2 this way. And then I'm going to be really careful and draw it the best that I can. Oh, that one is kind of far away. Oh, let's move this and cheat over. Okay, or you could use the circle tool. That would probably be smarter. Okay, I could just draw something. Good enough for government work. Okay, good times? Sweet. That's it. Be good. Do your work. Keep learning. Bye.